you folks, Quaternion here, and welcome to a brand new episode of our multiplayer first-person shooter tutorial, and sort of our little segment, our little chapter on making a bot. So in the last couple episodes, we ended up making this bot that walks between waypoints. He also faces the direction of the waypoint. In this episode, we're going to have the bot be able to fight us, and that requires a few different steps. We got to talk about what that means. So step one, I think, will be to have the bot figure out if there is a target nearby and to turn and face it. So let's take a look at what's involved. I have made a little bit of a change between episodes. Just when I start playing, it'll automatically spawn a bot just to save myself a couple of steps because we got a lot to cover this episode. So let's go ahead and pause. And we're going to go ahead and open up our bot movement code over here. So in our bot movement, this is where we control our facing. And right now, all we're doing is we are rotating towards our direction. We are facing where we are going, which isn't bad, but what we're going to want to do is actually, if we have a target, we're going to want to face that target. Doing this will also open up the idea that we may not have the bots instantly turn to face the direction that they're going in. They could slowly turn towards the direction they're trying to move in. We're gonna step towards that at some point. So the first thing we're going to do is, instead of writing to the rotation directly, what we're going to do is store things in a bit of a temporary placeholder over here. So we're going to create something like well, let's see. How do I want to do this? We're going to make a vector3 called something like look direction. Okay? And it's going to default to the direction that our character is moving. Something like that. So instead of setting the rotation here, what we're going to do is set it down here. And we're going to set it based on a look direction. At this point, nothing has changed. If we go back in, theoretically, we're going to hit single player, our bot will instantly spawn, and it will still face the direction that it's going. Excellent. But that means we can intercept things over here. We can override the direction we're supposed to face. So let's figure out where we should be facing. Now, by default, it's going to face the direction that we're traveling, which actually we could add a note. By default, look where we're going. But now we're going to see, do we have an enemy target in range? Because if there is, we should be facing the enemy target. Keep in mind, we don't have to change the direction that we're moving. In fact, this bot will continue to only cycle between waypoints. He won't walk towards an enemy or anything like that. The bots will have certain destinations in mind. They will go towards those destinations. They'll just happen to shoot you along the way is what we're looking for. So what does it mean to have an enemy target in range? Well, all of our bots and players, so all of our characters, have a team member component on them, which tells them which team they're on. So what we're going to do is we're going to cycle through all objects in the game that have a team member component. We can check the bot controller and the player controller. Both have these team member scripts on them. So what we're going to do is we're going to cycle through all of the team member scripts in the game. Now, the very first thing we're going to do is a very slow operation, okay? Because what we're going to do is we're going to do a for each team member, I don't know, TM, in game object. I'll explain what I'm doing in a second. Game object dot find objects of type team member, like that. So what this is going to do, this is going to check every single game object in the game and see if they've got a component called team member. If so, it's going to add them to a sort of an array or a list, return that temporary kind of array, and then we're going to iterate through each one of those. This is slow. Put a little note. Warning, slow. And it's not the sort of thing you want to do every single frame because it's got to check all these. Ideally, you stuff them in some sort of variable and you cache them and you different things and yada, yada, yada. We're going to leave it in for now because it's going to be perfectly fine for our testing, but keep that in mind. So we're going to go through each one of these and we're going to see, well, first of all, well, there's three different questions we have to answer. One of them I'm intentionally going to leave out for now because we're going to cause a problem. We're going to cause a glitch. And I'm going to leave it out so that we can figure out the glitch later. So the two questions that are left are, one, is it an enemy? And B, is it in range? So what does in range mean? We'll have some sort of, I don't know, float, aggro range. We'll set the range to like infinite right now. It's huge, huge range. This is the range at which it will sort of notice an enemy. We'll make that effectively unlimited at this point, but by putting in a huge, huge number. So that is that. So, okay. Let's actually back up a step here. before we figure out the range, let's figure out if they're an enemy. So what does it mean for it to be an enemy? If the team member.teamID is not equal to my own, so get component team member.teamID. If we're not on the same team, clearly we must be enemies. Note that this get component here, as of in Unity 4.5 and earlier, it's a little bit slow, but as of 4.6, it'll do some auto caching magic, so it'll actually be relatively quick, so that'll be fine. I don't know why it like changed colors there. It was the red bit. There we are. So this confirms that we're not on the same team, but there's a catch. Team 0 is our team for like renegades. Team 0, the way we have it configured, anyone on Team 0 is a free-for-all. They're the enemy of everyone, and they have no friends at all. So we should also check, actually, that if either one of us are on the renegade team, then that means we're also fair game. So we can do something like, if our target ID is 0, or they're not on our team. Keep in mind, this will also cover the case where if we're on Team 0, because if they're not on Team 0, then we go to this check, so they'll be on some other team, and if we're on Team 0, then we're obviously not going to be on the same team. So now we know for sure that our target is an enemy. And then we can check something like range. So if if the target dot transform dot position, actually one more step back, vector3 dot distance of our enemies or our target's position and our position. If the distance between the two of us is less than or equal to the aggro range, then we're in range. Okay, so target is on the enemy team. Target is in range. So the question is it closer than the other thing? So how do we track the closest? We just did this very recently with the waypoints. Well, what we need to do is grab a team member closest variable. We've got this placeholder. It'll start off as null. We don't have to be explicit, but for this, I think it'll help. We also need a floating point that keeps track of the distance between the two of them, and we do have to instantiate this to 0 because of reasons. So if we don't have a closest target already, if it's currently null, or if the distance between this target and our current closest target is less, then we have to use that as well. So we're already calculating distance here. So let's go ahead and cache this. Float d equals this. So d is the distance between the target and me. So if the distance between the target and me is less than the aggro range, and if we get down here, if we either don't have a closest target or the distance between this target and us is less than our cached distance that we're tracking, then set closest to be equal to this, and set distance equal to d. So the very first time through, assuming the person is on the other team and they're within aggro range, then the very first time through, closest will be null, so they will be assigned to closest, and their distance will be put in there. The next time we pass through this, where we find an enemy that's within range, we'll have to check to see, so clearly closest won't be null, so we'll move to this bit, and then the question will be, is this new target closer than our old target? If so, then that becomes our new closest target. So we look through all these things. I will point out there's still a glitch in here. Extra points if you found it already. So now that we've done that, we're going to change our look direction. So if, after all this, if closest is not null, if we have an enemy that's within range, then we want to change the look direction. We want to set the look direction to be the direction between us and the target, which we know we can do by going closest dot transform dot position minus our own transform dot position. This is the direction to our target, which we will set as our look direction. We will then convert that direction into a rotation, which will feed into our transform dot rotation. Now, keep in mind with this, and this was technically sort of an issue in our code before. This can cause us to rotate in all kinds of different ways. We actually only want to rotate around the y-axis. Because we don't want a person to tip over and pitch over to stare directly at the thing. We only want him to rotate around the y-axis. The y-axis is the one, so the y-axis is the vertical axis. So if we orientate ourselves, rotating around the y-axis means going clockwise or counterclockwise this way, which is what we want. We don't want our character to sort of flop over this way or that way. Now, by default, the character controller component basically locks us around only rotating around the y-axis. So I think this won't be disastrous. But just to be sure, we're going to do something like this. We're going to make it a little bit more explicit. Quaternion, this is going to be something like the look rotation is going to be equal to that, except we want to set it look rotation not Euler angles. We want to make sure we're only rotating around the y-axis. So let's make it really, really explicit. So we're going to do a new vector 3. The x is going to be 0. The y is going to be the look rotation dot Euler angles dot y. And the z is going to be 0 as well. So this should force the rotation to only be around the y-axis, just in case anything weird happens. We'll add some comments in a second. Let's go ahead and hit play. Go ahead, red team. And what's going on? He's not facing us, he's not facing his direction, and the log is full of errors. All right, what's the error? Look rotation viewing vector is 0. What the heck does that mean? Look rotation requires a direction. It's complaining that the direction it's getting is 0. It's like the vector is 0, 0, 0. It's a null vector. It's not. There's no direction. Well, how is that possible? Presumably, it's finding a target. Well, let's confirm. Let's say we back out. This whole like target detection stuff, all of this. Let's go ahead and like just cancel this. So let's hit the right key. So it will no longer look for a closest target. Closest will be null, so it won't do that. So it'll still use the look direction of our actual like direction. So we should be facing, the bot should be facing the direction that he's moving. And he is. So clearly, the problem is not any of this stuff. The problem is our look direction that we're getting from here. We're clearly finding a target. But for some reason, look direction here is ending up 0. How could look direction be 0? It could only be 0 if the difference between these two is 0, which means these two things are exactly the same. Have you figured it out yet? We have not excluded the third criteria in our list over here. We haven't excluded ourselves. We are finding ourselves. Much like someone attending, I don't know, their meditation class for the first time. They are finding themselves. The reason is we are on team 0. We're a renegade, which means everyone is our enemy. And we're not checking to make sure that we're ourselves. So let's go ahead and put in a little check right over here at the top of the loop. I say, if this team member we find, if it's equal to get component team member, if it's equal to ourselves, if it's literally the same component, then skip. We're just going to throw continue in here, so it'll just jump to the next loop. Here, I'll make it a little bit more explicit with some comments. How zen? We found ourselves. Loop to the next possible target. All right, now if we hit play, we'll get an error. Because, you know, characters are important. There we go. Forgot my closing bracket. Now, our target is indeed finding us. Look at that. Now, I will note that in addition to having unlimited range, right now, the bot can currently see through walls and can track us through walls. What we would want to do as a fourth criteria over here, you know, if it's not us, and if they're on an enemy team, and if they're within range, then we should put in one more check. To do a raycast to make sure we actually have line of sight. I'll leave that to an exercise, as an exercise to the viewer. Right now, it's going to be good enough for our purposes. So we have the bot will properly be moving, will properly be facing us. And again, if we had the right animations in here, they would be doing some side stuff and strafing and stuff like that as they're walking sideways. But again, for our simple things with very few animations, this is going to be totally fine. So he's going to continue his path, but he's going to face us. There is one thing that's missing, though. It's that the gun is not moving up and down. It's quite obvious here. If I'm uphill, and even if I jump, well, come on, path towards me. Or tell you what, we'll do this instead. I will throw myself off the cliff. The bot has basically unlimited range. If we zoom in on the bot and actually give it a little pause, the bot is still facing me. The bot is correctly facing me, but the gun should pretty much be facing straight down. The aim angle is not being updated for the bot. Let's go ahead and talk about that. So if we go into our player movement. I think it's player movement. In player movement, we do adjust aim angle. We have this function here where what we do is we check to see what the angle of the camera is, and then we orientate, we feed in some number inside of aim angle over here, and we adjust an animation. So we need to do the same thing for the bot. Now, this brings up an interesting point. At least I think it's interesting. The only thing in the player movement script that modifies our animation is this now. It's this aim angle. All other animations on our character are handled by the network character script. The network character script is responsible for actually moving our character and also adjusting our animations. For example, it is setting whether we're jumping or not, and it is setting our speed animation, which would let us cycle between idle, walking, running, strafing, or strafing, all those things, assuming we had animations for all of those things. This would be responsible for handling that. Not only that, it actually does process our aim angle a little bit, because if it reads it from a remote source. It sends, where is it especially? Right here. It sends other people what our current aim angle is, and it reads the aim angle back in. And then in the update over here for remote things, it slowly lerps the aim angle to be correct. So it already does all those things. So if A, we need our bot movement to also adjust aim angle, and B, the only time we use animations at all in the player movement is for the aim angle, I think it makes a lot of sense for us to take this aim angle nonsense and move it into our network character. I think that's pretty good. And the easiest way to like spot that this is happening is if we go ahead and remove the reference to the animator, we can see that here's a red line. Here's where we set the animation. And then the only other reference is down here. That's it. That's all. We don't use it anywhere else. Okay, so let's go. We're going to leave this line in for a second. Let's go over to the network character and figure out what we need to do. Well, just like we have this non-serialized public variable for direction and is jumping, let's go and create another one for angle, which is a float. I'll call it aim angle. We can finally get rid of that stupid capital A that I was never quite happy about. We'll have it start off to 0 by default, which will be fine. And we're going to just feed data into that. So here, we'll keep calculating the aim angle, but instead of setting the animation directly, I'm going to cut this line. Then I'm going to use my net character dot aim angle, and I'm going to set it to aim angle like that. And actually, I'm going to use my F2 key over here to go ahead and... That capital A was driving me crazy. I realized the animation had the capital A, but I don't know. Consistency. Okay, so now our player movement will feed this aim angle value into our net character right over here. And then we have to just update the animation at some point, which we can do. Why don't we... I'm starting to think we actually want a function here. We have a do local movement. We might want to do local animation. But for now, what we'll do is we'll adjust our aim angle animation, and we'll just basically do that, so with proper spelling. There. Now if we go ahead and hit play, my character's aim angle should still work, and indeed it becomes very obvious if we zoom in on our character over here and I do that. Aim angle still working correctly. It's not a great animation, just like everything else, but there we go. So we've got that going on. We're still fine. So now let's get the bot to do the exact same thing. I do apologize, there'll be a teeny tiny little bit of math over here. So, just like with our look rotation, we wanted only rotation around the y-axis. Well, now we sort of kind of want the opposite. Now we want to know what kind of rotation is required on the other two angles, the other plane. Let me present it a slightly different way. Let me go ahead and zoom out over here and just drop a character into the game. So assuming we're facing forward towards the z-axis, then what we're interested in is our rotation about the x-axis. The x-axis is the red arrow. So what we want to know is how much rotation around the x-axis is required to face our target, and that's our correct aim angle for our animation. You dig? Now, of course, it's not going to be the x-axis if we're, if we're turned... Whoa, that's not what I wanted to do at all. If we're turned this way, it's going to be a combination of x plus z if we're on the global axis over here. Although if we're on the local axis, it'll always be around the x, which is kind of an interesting thing to consider, actually. Let's talk about that. So there's a couple of different ways we can go about things here. I would say that the best way to do things, again, it will require a little bit of math. What we're going to do is figure out relative, after we're done our rotation, and here we have, we've rotated ourselves. So we now should be facing our target. Based on our facing on the target, since we're facing straight ahead right now, we want to know how much rotation about that x-axis is. So the math to do that is first we would like to find out the distance between us again. Now we have look direction. Look direction is basically yeah, at this point, look direction is basically a vector that points from us to our target, but it's in global coordinates. We can get that converted over into local coordinates, so it takes into account our rotation and everything, and it'll just tell us how far ahead and how far up or down our target is, just like that, based on our local coordinates. So what we need to do is this. Vector 3, we can do something like local look direction. And we can use a function, transform.inverse transform point. Actually, what's the... I have to be honest. I'm using inverse transform point, but I'm wondering if inverse transform direction is what we want. I don't think so. I don't know what difference it makes. Anyway, let's move on. This should work. Well, we'll see. If it doesn't work, I'll double check my documentation over here. So we're going to feed it in our target. Oh, I think I realize the difference is I can either feed it direction or I can feed it my target point. So if I'm using inverse transform point, I give it my closest.transform.position. Oh, closest.transform.position, like so. So I can give it the point. Or what I could have done is, if I'm using inverse transform direction, I could have just fed in look direction. But this will be fine. So what this will do is it'll give me a local look direction in local coordinates, which means, assuming I'm facing towards the target, the x component of this should be 0. We could verify that. Actually, let's go ahead and do that. Let's go debug.log, and let's have it spit this out. So now, no matter what, the x component of this should be 0. It should just give me a z, which is basically the distance on the horizontal plane. So I just rotate in some direction so I can see the landscape in a way I'm happy about. There we go. So the z, assuming we're facing, say, directly to the right, the z will just be the distance this way to the target, and the y component will just be how far above or below us the target is, and that's it. There should be no x component whatsoever because we are facing our target. Let's go ahead and get rid of this dummy bot controller. Let's hit play and then see exactly what the text tells us. And it does. You can see the x is always 0. And then the z is the distance as it passes by us. It'll go down to 0, and as it gets further away, it'll go up. And if I were to bounce up and down, you can see the y component changes, and especially as this guy goes up and down the hill. All right, that's exactly what we want. So now that we have those, we can do a very simple piece of math to get an angle. We actually looked at this in a 2D tutorial recently. Float. So our target angle, the angle towards our target, or the aim angle, I suppose, is, well, I guess we could say target aim angle would be fine, is mathf, so it's the floating point math library, atan 2, and we want this local look direction, the y and the z, or z. So what this will do is this will give us an angle in radians, I suppose, made by this triangle, right? This is like we're calculating a right triangle. The height of one side, the height of the other, and then something math things. Anyway, it's in radians, so we got to convert it over to degrees. Listen, it's been a long time for me since I've been in trigonometry or whatever. Trigonometry, geometry, one of those. So this should be the angle. We'll go ahead and test it in, well, right now I guess we just have to feed in our target aim angle, like so. That is not what we want at all. Dot aim angle. All right, let's figure out if this works. So we hit play. Single player, red team. All right, I mean, it doesn't look apocalyptically wrong. What's most telling is if we go and throw ourselves off the cliff and then pause, zoom into our bot controller, there we go. He's pointing down. Let's go and take our player controller and change our height to like 10,000 in the air. And then unpause it. There you go. He's pointing straight up, as high up as the animation goes. So now the bot will correctly point their gun towards us. It's actually not an effect that's going to be completely obvious once we play. But there we go. Let's throw in a few comments so we can explain what's going on. So we're looking for an enemy target within range. We've got that. We've got that. Is the target closer than the last target we found? If so, it sets that. We get here. We have a target. So let's use that direction as our rotation. Or our look direction, I should say. Look direction. Rotate towards our look direction. Figure out the relative vertical angle to our target and adjust aim angle. Although this should also only work if we actually have a closest target. So this is only if closest is not null. Otherwise, we don't have a target, just aim casual. So we're just going to return to the neutral aim angle of 0 at that point. Okay, that's pretty good. Now, how do we get this bad boy to shoot at us? Man, oh man, what's my recording time? Do we need another episode? Oh God, we need a whole other episode probably, because we're kind of there. There's going to be a few things for us to do. But, well, I guess that's fine. Hopefully you guys are still groovy with everything that's happening. And we'll see you guys next time. Bye-bye, folks.